Hey there, Skywatchers. You're tuned to the Astronomy North live event. A geomagnetic storm watch is in effect for Earth right now, and we're watching to see if there are any active auroras above Canada. I'm James Pugsley. I'm with the Astronomy North Society. We're a nonprofit group based out of Yellowknife, Northwest Territories. I'm coming to you live from Whitehorse in Yukon. And we're covering lots of different things tonight. It's going to be a long night. There could be a G3 strong geomagnetic storm event as we see the latest forecast or the latest storm watch information issued by the National Oceanic and Atmospheric Administration suggests that we could reach G3 storm levels tonight. But here's the asterisk on all of this is we could also reach G2 levels. We could also just reach G1 level, which is a minor storm, or we could have absolutely nothing happen at all tonight. That's the mystery of the Northern Lights, and I guess it reveals how challenging it is to predict these sorts of events, and that's fine, because it's the way it goes when you're trying to predict space weather. And so my job tonight is to just help you enjoy the show and see if we can see some auroras across Canada. And I'll be monitoring the weather systems. I'll be monitoring space weather conditions, checking in on social media to see if there's some activity on a couple of different accounts. And we'll be checking Aurora cams regularly just to see what's going on the cameras. And while I'm saying that, I'm just going to pull the screen aside here, and we'll see what's happening live from Churchill, Manitoba. One of the few cameras that's currently on. And if you were interested in finding out or seeing that camera for yourself, it's on the explorer.org group of live feed cameras. Really cool, unbelievably high quality footage of the sky. I mean, I don't think it's doing it justice right now on this feed, but you may be able to see like how sharp those stars are on the Churchill camera. So what we're watching for there, aside from the bright red light from the tower, is to see if there's any activity overhead. And kudos to the team that's managing that camera. They actually are able to pivot the camera so it can look in different directions. So if we have active northern lights to the north, it can turn north. If it turns south, that's even better because that's suggesting that we have likely got a substorm or a bigger brightening of the aurora. So we have increased activity. Why do I say that? Well, if you have increased activity to the south of Churchill, it means that you're seeing northern lights likely in northern Ontario, southern Manitoba, southern Saskatchewan, mid to southern Alberta, and if it's dark enough at that time, mid to southern BC. So we're going to keep an eye on all of that. On the screen right now, a couple of my sort of favorite tools to keep an eye on leading up to a geomagnetic storm. One is the WSA NLIL CME prediction monitor. CME is a coronal mass ejection, so that's a gust of solar wind coming from the sun. And you can see it in the top right-hand corner of the screen. It is showing these large spikes. I'll just enlarge the entire frame here so we can see that. Get off of there. Okay. So this is our current situation. The current prediction for the arrival of a coronal mass ejection. And so what are they predicting here? Or what are we seeing here? Well, sometimes they call this the pinwheel. And the pinwheel is showing us the view of the solar system from above. And so you see 4 dots on the pinwheel. The first dot, dead center, that's the sun. And all these streams that are coming away from the sun or spinning away from the sun, that's indicating, of course, that the sun is rotating on its axis. And it is emitting charged particles in pretty much every direction. In some areas, it's more intense emission or eruption. And in other areas, it's relatively quiet, and the solar wind is not very fast and it's not very dense. But that's what the pinwheel is representing. It's the view from above of different currents or different streams of particles heading outwards from the sun. The other three dots, two of them are the stereo satellites, and one of them is the Earth. And right now, the two dots that are the satellites are on either side of the Earth. So green, if you can see the green on the live feed, the green represents Earth. And we see it, I'll say in the spiral that's in the bottom left, I don't know if you can see the mouse. We can see the red is representing stereo A, which is graphed here. The purple is representing stereo B, or maybe it's blue. No, it's purple. And then the green is representing Earth as that third satellite, if you will. It's a satellite of the sun, but it's also there to help us measure what's happening. So we are, in essence, providing the same data collection as the two satellites in orbit on either side of us. And so what are we monitoring with this? Well, in the lower spiral, we're monitoring solar wind speed. They're calling it radial velocity, but let's just think of it as solar wind speed. So this is showing over time with August the 15th, 16th, 17th, and 18th, all the way to the 21st, mapped out at the bottom of the graph. We can see that the solar wind was projected to be on the decline up until the 18th, and then we were to expect a coronal mass ejection, or a gust of solar wind. We can see them launching out here from the sun, was going to arrive at Earth, impact the Earth's magnetic field, and that, of course, is what will help trigger active northern lights. So we're watching to see if there is an impact. If there is an impact, how significant is that impact is the next question. If it's a major impact, it could lead to active auroras for many hours. It could lead to active auroras for many days. So we have lots to watch for tonight, because there have been multiple coronal mass ejections, as we see, both from the bottom spiral, or from the bottom pinwheel, as well as the top pinwheel. Now, the top is showing the density of the plasma, or density of the gust of solar wind. And why that's important is you can have a really fast, really intense gust of solar wind that is... sorry, I just turned up the volume just to make sure the microphone is working. It's important when you're doing a live event that the mic is on. I don't know if anybody is tuned in right now, but for the first 25 minutes here, I didn't have the mic on. I wasn't really saying much because I was trying to build the page you're looking at right now. But anyway, where was I? Oh, yes, density. Ironically, I was talking about density. Okay. So when we think about the density of the solar wind, it means like you can get hit by a very rapid, very fast solar wind. But if the particle stream is not that dense, in other words, there aren't a lot of protons in it, it can lead to a mild impact. Whereas imagine you had a very dense solar wind, but it wasn't moving very fast at all. Well, that can actually lead to turbulence in Earth's magnetic field as well. It depends on the magnetic polarity of that incoming solar wind. And this is getting complicated here, but just imagine that all those gusts of solar wind come with their own magnetic fields. And when they arrive at Earth's magnetic field, that can lead to either an attraction, when you have a north. So generally speaking, Earth's magnetic field has a northward tilt, as they describe it. So if we have a southern magnetic structure, a southern tilt on the magnetic structure, or it poles, essentially think about a bar magnet. When you have north and south meet, the interaction is strong. When you have north and north meet, so imagine those incoming gusts of solar wind that we're seeing there are both have a northern magnetic polarity, then we will not have any activity at all, like none. Earth's magnetic field will reject any incoming particles and they'll just deflect away. And that's the way it goes. And that's something we cannot really predict. You wouldn't know that until the coronal mass ejection has arrived at Earth and the impact has occurred, or that it's swept past. Another window that I have open here is the main page for the Space Weather Prediction Center website. And I enjoy the page. It's a good page because they've created a dashboard that's just for us, the sky watching community. And that's pretty cool. They didn't have to do that, but they did. So thank you, Noah. And maybe what I'll do is I'll just give you a quick introduction to this page because it's got lots of bells and whistles on it. And it's important to kind of know what those bells and whistles are telling us. So the dashboard itself, maybe I'll zoom back so you can kind of see the full dashboard. I don't know if I can do that or not. Yeah, here you go. So you get a sense of the dashboard when you zoom back. It has pulled in a lot of the models all onto one page, models that are showing solar flux, solar information, models that are showing space weather information, models that are showing forecasting data, solar data. It's the whole package. So if you're into aurora viewing, the thing that you're looking for on this page, I'd say that is of most significance on a night like this, is down here. Now I've got to zoom in again. Let's zoom up. This is the real-time solar wind data. Let's see if I can go even bigger. There we go. Why not? Real-time solar wind data. And what does this tell us when we look at it? Well, one thing that it definitely tells us is that we have a relatively unsettled situation going on tonight. And that's in large part because there does appear to be some significant activity underway. Where's the evidence of that? Well, look at the red line and the white line at the top of your screen. It's showing the tilt of the magnetic structure following the arrival of some solar wind gusts. And the evidence of this is that there is a significant spike happening. And now I'm just going to, this is real time, but this is showing not the time scale that I'm hoping for. Let's see if we can find a closer time scale, take a closer look. That is zooming the wrong way. There we go. Let's see if we can take a closer look at where things are at with the solar wind. So we see that the solar wind speed is currently 550 kilometers per second, which is relatively fast, but not an indication of a major spike at this moment. So, it's been hovering between 400 and 550 since this afternoon. And I'd say I think it was around, well, I won't even have to talk about it. Let's just take a look. You can see there was some increased activity, geomagnetic activity, with these yellow bars suggesting we reached a G2 storm already this evening. Now, in Western Canada, the sun hadn't even gone down yet. This activity was largely above the eastern part of Canada, and it's unclear whether or not we had visible auroras at the time because the sun was just setting, but I will be checking the social media streams shortly to see what we have, see if we had some people get some cool pictures today. So where was I? I was going to go and check out our solar wind speed because I just saw that there was, of course, a major spike where we saw the BZ tilt down to almost -10, which is really good news from an aurora viewing point of view. The other element, so when we see that red line dip all the way down here, that's telling us that there is some unsettled activity going on in Earth's magnetic field. And it reached, I love the new dynamic real-time solar wind data set. The way they've set this up is awesome. So we reached a -10. Currently, we're at -5. Here's, in a nutshell, a good way to read or interpret this data. If you see the red line is below this 0 marker, knowing that the far right-hand side of this data set is the current time. What is our current time? 5:43 universal time, which is about 10:43 if you live in Pacific time right now. So here's why that's relevant, is that if you see that red line, this red squiggly line dipping below the white line marking 0, that means auroras are likely visible. It's as simple as that. If you didn't know that already, I hope that was a good nugget of information for you to amaze and impress your friends. That's what this is all about. Amazing and impressing your friends. Okay, I'm just checking some of our following on YouTube. Welcome if you're just joining us. This is a live event, Astronomy North live event. We're covering the geomagnetic storm watch that's in effect for Earth, and that means we have a geomagnetic storm watch in effect above northern Canada, Alaska, and southern Canada. If this gets intense, we could see active auroras at mid-latitudes. And so we're going to keep an eye on things over the next few hours and try and give you updates and just keep talking about this aurora experience that we really have. You know, we're really at an unprecedented time where we can have these conversations about the Northern Lights in real time from any place on the planet, which is so cool. We sometimes take it for granted that on your phone right now, you can be checking this feed. You can be watching an aurora cam in real time. You can be checking the latest solar wind speed. All those things are in your pocket. The only thing that has to happen that's not on your phone is that you need to get outside and go out and see if you can see the lights. And if you're, if you're like me, the Northern Lights are kind of a common experience for me because I live in the north, and we see the auroras almost every single dark night, and the darkness is finally returning to northern skies, so we can expect to see more and more activity, more and more nice auroras in the months ahead. And so that's awesome. But if you live in the south, yeah, I mean, a lot of folks who live in the south don't get to see the auroras very often. So this is one of those nights where you may be the luckiest person in the country. You may get to see the big show directly overhead, and I'm hopeful that this feed will help you. So if you're just joining us, I'm James Pugsley. I'm with the Astronomy North Society. We're based out of the Northwest Territories. I live in the Yukon, and I'm providing this support as a volunteer. Why? Because why not? That's what I say. Why not? And what we're looking at a couple of different tools that are available to you if you go to the National Oceanic and Atmospheric Administration's website. And these tools are awesome. Not all of these things are on the NOAA website. The bottom right-hand corner of your screen, I've just cut it off, unfortunately. Let me see if I can correct that. The bottom right-hand corner of your screen is showing the live feed from Churchill. There we go. That's a bit better. The live feed from Churchill, and it is telling us that, again, the auroras aren't yet visible, not above this camera, or at least not in the direction that it's facing right now. On the left-hand side, we have another camera. This is the Themis camera, which is Themis is part of a project that's a partnership between NASA, the University of Berkeley, California, and the University of Calgary in Canada. And the University of Calgary are leading the effort on the ground. They have been setting up the ground-based observatories that are essential to that project. And a great team at University of Calgary. And why do I say that? Well, not just because I know them, but because they are partners in Aurora Max, which is one of the projects that Astronomy North is leading. And it is monitoring the intensity and frequency of the Northern Lights above Yellowknife Northwest Territories, Canada. We've been doing that project since 2009, so we have quite a lot of data now, and we're trying to pull that data together to help better inform the Aurora tourism industry in the Northwest Territories, but also give us all a better understanding of what it means to live at 68 degrees north magnetic latitude, which is where Yellowknife is located. Okay, it is approaching 10:55 local time in Yukon. And if you're in Toronto, you are now approaching 1 a.m., 2 a.m. if you are on the East Coast, 2:30 in Newfoundland. And we are still waiting for the arrival, the big event that was forecasted for tonight. It hasn't happened yet. Doesn't mean it won't happen. No guarantees that it will, of course. But still lots to come. I'm just going to take a bit of a break away from the microphone. So stand by, and we'll keep the data set and some of the cameras live on the screen here so you can continue to monitor space weather conditions, monitor that solar wind, and then we'll just get back to you shortly with some social media updates. Hey Skywatchers, it's James Pugsley with Astronomy North, and it is now midnight local time in Yellowknife. We're monitoring the geomagnetic storm. The prediction is a possible G3 strong geomagnetic storm tonight, and currently we're not seeing that, and that's not out of the ordinary. I'll tell you, they predict these events based on projections about the rate or the speed that the the speed that the solar wind is traveling, with the expectation based on the data from the sun that they can predict, give or take within 6 hours or so, 8 hours or so, when a gust of solar wind may arrive at the Earth. And sometimes they get it wrong, or sometimes they're off by a bit. You know, they may be off by a couple of hours, they may be off by many hours, and or they may be off entirely. That the prediction was something was going to collide with Earth's magnetic field, and every now and again, you just get it wrong. That doesn't necessarily mean, though, they got it wrong yet. That's why we're doing these live events now, is to try and keep an eye on things, because we could see a significant bump in solar wind speed. We could see a significant surge in the solar wind that leads to turbulence in Earth's magnetic field, that leads to nice auroras across Canada. So that being said, we are monitoring everything tonight, and I'll be here to try and help you navigate this storm, no matter where you live in Canada. This is a pilot project tonight. In some ways, we're trying to test to see how is it to do a live event that is focused on geomagnetic storms, knowing that I could be potentially up all night with you. And if you're listening on the other side of the world, welcome. It's probably sunny where you are, so your aurora viewing opportunities are going to be extremely limited. But for Canada right now, this could be a great night. There are imagers coming on across the country. So we're watching the Themis array. Themis is a project that is a partnership between the University of Berkeley, California, University of Calgary, NASA, and the Canadian Space Agency. And it is monitoring the geomagnetic field. It's also monitoring auroral activity. And the way we're monitoring the auroral activity is from the ground. So there are a series of ground-based observatories, and the University of Calgary has set these up across the north, so including Alaska, Yukon, Northwest Territories, and Nunavut. But you can also see there are cameras in Alberta, Manitoba, Saskatchewan, Ontario, and Quebec, and Newfoundland, Labrador. They even have a camera up there in Greenland. Anywhere you see blue, though, so the circles represent the field of view of the camera, as it is part of an array of cameras. They are pinpointing, generally speaking, the view from the ground, looking up, with some overlap with other cameras. Anyway, if you see the blue on those cameras, that's indicating that the camera didn't come on. So there's a technical issue, or if you look out west, if you look at the Alaska cameras there, they haven't come on yet because may not be dark enough. So each of these cameras has sensors. The sensors can help detect when to turn on, when to turn off, based on, I believe it's based on where the sun is located on the horizon. So I think once it dips below a certain point on the horizon, the cameras will turn on. And meanwhile, NASA launched a number of satellites. I think it was back in 2000. I want to say 2007, but I might be wrong there. The satellites are in orbit, monitoring Earth's magnetic field, and they're on certain orbit that allows them to detect when something occurs out in our magnetic field. And so if they detect it out in the magnetic field, and then they see the live event happen film from the cameras, they can show cause and effect. In other words, there's something that happened in that magnetic structure, and here's how it correlates to what was visible from Earth. And this was really important in a discovery back in the early part of the 2000, actually within, I think, just a few months of the mission launch, they achieved their mission objective to detect a geomagnetic storm event or a substorm, and that was triggered by magnetic reconnection. And so it was able to detect when a magnetic reconnection event had occurred in Earth's magnetic field and the subsequent auroras that were visible on Earth. And it was a breakthrough. It really was. But what do we use it for from an aurora viewing point of view? Well, you'll see once we get active northern lights, could be tonight, could be any night. We see almost every single night in the north there are some active northern lights at some point in the evening. But anyway, you need a clear sky. So these cameras in an array can show you that sky. And when you're looking at it right now, this is the live feed from across the country. And when you're looking at it right now, what you're probably looking for, what you are looking for, is to see if there is a line forming across the country. A line meaning an arc of auroras, hopefully that is visible, bright enough to be detected by the cameras. And that gives us an indication of how intense things are getting across the country. And so we're going to keep an eye on that series of cameras monitoring auroral activity in real time across Canada, thanks to the University of Calgary, University of Berkeley, California, the Canadian Space Agency, and NASA. All right. I'm just going to do a quick check of a few other instruments that are out there right now. We can see, of course, again, down in the bottom right-hand corner, a live feed from Churchill, Manitoba. Oh, you can't see that in the bottom right-hand corner. I can. Let me just switch that up so we can take another look at our current conditions and the latest from Churchill. There are a number of cameras that aren't on yet in the north. The Aurora Max Observatory is one. It's not on yet. The anticipated kickoff of the season for Aurora Max is a few weeks away. So for now, because we have a geomagnetic storm mid-August, we can work with the cameras that we know are on. And I'm going to check Alaska shortly and see if we can see that. So anyway, here we go. So we're back to looking at Churchill in the bottom right-hand corner. And this is a cool camera. It is on explore.org as one of their awesome live feeds. And we see, of course, the bright red light of a tower right in the line of sight there. But it's also telling us whether or not we have active lights overhead. I don't know what direction this is facing. It's not really showing that information on their live feed. But you can go there yourself. It's explore.org is the site that is, they're the awesome folks that are hosting the camera. I'll just pull up the whole thing. And look at that. There are 86 people watching explore.org. Kudos to them. It's a great camera. Really awesome definition. You can see the stars in detail. You can see auroras when they're active. But what is it telling us right now? I'm not here to just look at the camera. It's telling us that there are no active auroras above Churchill at this moment, at least not in the current direction that the camera is facing. And so that's important to know. The other important item to know is when we look at the current solar wind speed located here. Let's see if I can shift that so it's in a better position. The current solar wind speeds are suggesting we are hovering around 550 kilometers per second. I'm just adjusting a few settings here. Hold on one second. Come on. Solar wind speeds are hovering around 550 kilometers per second, which is above average, but it is not the major event yet. So, that being said, doesn't mean it won't happen tonight. It just means it hasn't happened yet. If you are still awake, if you're in Eastern Canada, just remember, keep an eye now on the northern sky. You're going to start to shift your viewing from looking northeast to northwest. So if midnight has passed where you live, now you're going to want to start to look to the northwest for activity, or overhead, or to the north. It's less about looking east. If you live in, well, let's take just a scan across the country and see if we can see what you see. So if you live in Newfoundland, Labrador, you are looking north or looking northwest right now to see if you can see active northern lights. The current situation suggests you're not seeing them based on the real-time auroral oval. And let me pull that up. I can pull it up on this screen here. So our solar wind speed data, we're pulling this, of course, from the Space Weather Prediction Center website. So let's take a closer look at our 30-minute aurora forecast. The 30-minute forecast model is created to help us all better understand the last 24 hours and the next 30 minutes. So that's what we see, and we'll look at the Northern Hemisphere first. And I'll just play the video because why not? Because Noah's done an awesome job to pull this stuff together. And so when you look at the current situation right now, this is not the current situation. These are the hours leading up to the current situation. And there is a flare up coming up right here. And this was likely the arrival of the first gust of solar wind, the first coronal mass ejection. And it led to visible auroras above Scandinavia. So we can check and see if there's some data showing Scandinavian situation. It appears as though that suggests that the coronal mass ejection arrived a little bit earlier. And what else does this tell us? Well, it tells us that, as of course, what we're seeing here is that the Earth's rotation is shown with the movement of the dark shadow of the planet versus the sunward side. So I'm just going to pause the video here and give us our current prediction, which is if you go to the far right of this tool, it gives you the current prediction. So this is showing us their prediction. In the bottom right-hand corner here, it shows us the prediction for the 18th of August, 2022. The model run was at 6:10 Universal Time. So that's 11:10 local time in Whitehorse. 12:10 local time in Yellowknife. I hope I got that right. It's sometimes a little hard. It's getting close to midnight here, so my math might be a bit off. Anyway, you get the idea. And so what it does is it gives you a window to the next 30 minutes based on current incoming data and projections. So, what was I talking about? Oh, yes. Well, just that it appears as though that the CME, the gust of solar wind that was expected to cause the most turbulence, has already arrived. It may have arrived earlier today. And so let's take a closer look at our CME monitoring system here, the WSA Enlil solar wind prediction model. And the solar wind prediction model, if I can pull that up, there we go. And again, if you're just joining us, you're watching an Astronomy North live event, the Geomagnetic Storm Watch in effect for planet Earth, which means that there is a geomagnetic storm watch right now in effect for northern Canada and southern Canada. So if you're watching, this is a good night to be out looking out for auroras. It truly is. That being said, we still have not had the big event yet. There was an event earlier in the day. It was visible. It led to visible northern lights above Scandinavia. And that's great. But the prediction was that it was going to lead to some active long duration auroras above Canada. And we still haven't seen that yet. And ladies and gentlemen, that's normal. It's normal. The predictions aren't always right. In fact, I think I can safely say a lot of the predictions are off a bit. And I think I have a theory about that, but I'll get to that in a minute. Let's just talk about what we're looking at here. So the pinwheel is showing us the view of our solar system from above with the sun at the center and these streams spiraling out from the sun representing the solar wind streams. And so on the top pinwheel, we see two viewpoints, two vantage points. The first, let's see if I can zoom in this up a bit. Can I zoom it up? Well, that's probably a bit better. Is that better? Looks a bit better. Okay. It's not perfectly centered, but we'll go with it. All right, let's try that. I'm just going to, hold on a sec here. We're going to cut that in. There we go. Okay, so a couple of vantage points to consider here with this tool. A really cool support tool for those of us who need to know. We need to know when the solar wind is going to arrive at Earth. So this is the tool that helps. It's a model that is doing its absolute best to show you in 2 dimensions what's happening in 3 dimensions. How does it do this? Again, looking from above, we can see the sun rotating on its axis and launching particles out in all directions. So the top pinwheel, I'll see if you can see the mouse on the screen. I don't know if you can see that or not. Anyway, the top pinwheel is indicating the density of the solar wind. The lower pinwheel on the left is indicating the speed of the solar wind. So this green stream represents faster than the blue. The yellowish hue here represents faster than the green. And then we have these blasts heading outwards from the sun that just happen to be pointed at Earth. And those are telling us that the speed, the rate at which they're traveling, is elevated. The prediction was that a relatively dense gust of solar wind, as indicated by the pinwheel at the top, was due to arrive at Earth, this green dot, which has 2 satellites on either side of it. Stereo A, which is the red satellite, and Stereo B, which is the purple satellite. The green dot in the middle is Earth. And the expectation or the prediction was that a relatively dense gust of solar wind was due to arrive at Earth on the 18th of August. So when we look on the chart on the right, it's trying to illustrate what's happening on the left, and it's showing the density of the plasma as it approaches Earth on the 18th universal time. So let's go back to the moment when the particles are due to arrive at Earth. So the predictions, the early predictions, are shown here as being early on the 18th universal time, which is ultimately late afternoon, early evening on if you live in Canada. So where do I see that if I just peruse the Space Weather Prediction Center website? Well, you see it in the forecasts, the geomagnetic storm forecast or the geomagnetic field forecast, where it will just simply say whether or not it's going to be a G1, G2, G3, KP5, KP4, KP3. Those are the different different levels of intensity of the magnetic field turbulence or magnetic field structure as it is interacting with these particles. It can lead to very turbulent events, and turbulent and unsettled conditions mean active auroras or really nice auroras overhead if you live in the north, and potentially some in the south. So when we look at the 2 pinwheels, we're looking at a bit of a story. The story is simply telling us the dense particles were due to arrive late on the 17th above Canada. That's great news. So that's why there was an alert issued today from the Aurora Max group. The alert was intending to give everybody a heads up that there could be active northern lights above Canada. And that's what triggered this live event as well, which is the first of its kind. So, hey, welcome. Glad you're here. Get used to it, I guess. I need to get used to staying up late and drinking lots of coffee, but that's nothing new. If you don't know who I am, by the way, my name is James Pugsley. I am a volunteer with the Astronomy North Society, and we're based out of Yellowknife. I live in Whitehorse, but our society is pan-territorial, and we're doing our best to keep you informed of what's going on above Canada's northern sky, but also to talk about what this could mean for the sky above your community. And that's kind of the goal here. We're so used to seeing the northern lights in northern Canada that it actually means we should be doing more to support you no matter where you live. If you're not from the north, I hope this is going to be a helpful support service for you, or a helpful way of connecting you to the northern lights when it's cloudy. At least we can all enjoy the show. If it's cloudy, we can enjoy it together. All right, so back to this chart. So on the 17th, impact was due. It was going to cause some serious geomagnetic storm events, is what they were calling for. It originally was a prediction of a G1 minor geomagnetic storm that quickly elevated or escalated to a G2. Why? Because a lot of these storm events, or these solar, they're sometimes called solar storms. I'm not a big fan of that term. I hear some of the experts use that term, but I haven't really used that. A gust of solar wind is probably what I would say. These gusts that are coming out of the sun, you can see them on the illustration, the top illustration there. Once there was 1, and then 2, and then 3, and then 4 pops from the sun from the same general active region, they decided that was going to lead to a compression, a much faster, more intense event. I don't have to say it that way. It was going to lead to the compression of multiple gusts of solar wind, faster ones passing or interacting with slower ones, and as they arrived at Earth. And you can see it there in the top. You can see that multiple gusts of solar wind are interacting, and then they're arriving at Earth. And that's what I think got the attention of NOAA, the Space Weather Prediction Center team, is they said, well, if in fact those waves of particles, those incoming gusts, all actually hit the Earth, it could lead to a G3 storm, which is a strong event. It's a scale from 1 to 5, and 3 is pretty powerful. And that's important to note because they want to make sure industry is aware of the possibility of a G3 storm. From an aurora viewing point of view, it's definitely frustrating when you hear that there's going to be a G2 or a G3 event. You go outside, you wait, and you see nothing. It's definitely frustrating. But I'm kind of used to that with the Space Weather Prediction Center. They're not trying to make us happy as aurora watchers. They're trying to let industry know, and the military know, and the aviation industry know of a potential threat to their instrumentation. Fair enough, I guess. But for that reason, if they're wrong, no harm done. If they're right, at least they gave everybody a heads up. So I think from a from a sky watcher's point of view, we get frustrated with these forecasts if they're wrong. But in truth, in all honesty, it's okay. We have to be mindful of why they are issuing these alerts. They're issuing them in the event of a direct impact. It could lead to major challenges for some key industries. And, I guess that's an important piece. I personally, I love filming the Northern Lights. I love knowing when they're about to happen so that I can make sure the cameras are all set up. But I'm pretty sure NOAA is not that concerned about whether or not I had a great night of filming, or that you did as well. All right, so this pinwheel, these pinwheels are very helpful for predicting incoming gusts of solar wind. I encourage you to check them out. They're on the Space Weather Prediction Center website. You can see that. You might be able to see that anyway. It's at the swpc.noaa.gov, and that's part of the Space Weather Prediction Center website and all the different tools that they have. Okay, let's do another check of the cameras. So where are we at? In Churchill, we're not seeing a lot of new information there. We're seeing the live feed is still live. We have in the bottom right, not a lot going on. There's a bit of a greenish haze on the right-hand side of the camera. I don't know if you can see that or not. Let me see if I can enlarge this a bit. Yeah, so there's a bit of a greenish hue. That doesn't necessarily mean auroras are active. It just means there may be some residual auroras, diffuse auroras left over from earlier in the day. We can certainly say that this camera is, by and large, awesome. And why do I say that? Because look in the top left, you can see the Big Dipper. This is a video camera recording the sky. And the quality is good enough that you can see stars. And not only that, you can see them as pinpoint pricks of light against a dark background. That is awesome. And now when the aurora comes out, it's also awesome. It's awesome because we can detect that level of light thanks to the team at explore.org, thanks to the team in Churchill that helped set that camera up. And there, I think it's on top of a research building there. And I once called them to see if they, had some more information about the camera. And the lady who answered the phone didn't even know there was a camera on the roof. But they should know. They should be very proud of this camera in Churchill. It's very cool. But look at the stars. Look on the top left. You can see the Big Dipper. I love that. And as we get into darker and darker nights, more and more stars will appear on this cam. But we're not here to look at stars tonight. We're here to watch for auroras. So anyway, the bottom line is it appears as though we do not have active auroras underway in Churchill. Let's take a closer look at our national situation with the folks who created the Themis imagers. And so I'm just going to pull that up here. Just give me one sec. Oh yeah, this is a very professional live stream, ladies and gentlemen. We do this right. It's me trying to work the magic. I've never worked with this software before. I'm trying to work the magic, get things laid out so it looks decent for you guys. All right, here we go. We'll do a fade. Look at that. That's pro. Okay, so we're looking at the live feed showing Themis imagers, the feed from across Canada. A number of imagers are currently down in eastern Canada. That's what you see as the blue dot. Oh, wait a minute. We have activity above Churchill, ladies and gentlemen. There it is. It has begun. Oh, or is that a highlight? Oh, okay. Don't worry, it's a highlight. It's a feature of the explore.org cam, as they will post some of the highlights of the night. So this may have been earlier tonight. It's hard to know for sure. I do note that the red light is no longer on in the tower there. Let's see if we can put this back up on the screen in full screen here. Because I'm not seeing that on the Themis cameras. We're seeing it. We're definitely seeing it on as it was fooling me because it looked like it was live. It is not live. That is not a live feed from Churchill. But let's just put it up anyway as an acknowledgement of how cool this camera is. Okay, here we go. I'm just going to put it up now. There we go. There it is. There's the live, sorry, not a live feed. There is one of the highlights of the night. And things that again, I think I mentioned this earlier. One of the things I really love about the camera in Churchill is that it can move. Somebody is controlling it. They're keeping an eye on things. I'm assuming it's somebody, it's not just a sensor. So if you're out there, person, The person who's handling this camera, thank you for all that you're doing. It is awesome. And again, look at how sharp things are. I mean, you're seeing that as a feed through this feed, and you can still see a lot of detail in those auroras. So what's happening there? There we go. There's back to the live feed. Not quite as exciting. I love that they do that, though. It's a teaser. It's why we stay tuned to these things. It's showing us what we have hopefully got in the hours ahead. It's the hope that we're going to see some of this activity in the hours ahead. Okay, well, that was cool. Thank you, Churchill. All right, so I'm going to change it up again. We're going to go back to the national picture. Sorry about all the clicking. All right, there we go. We'll go back to the national picture. So this is showing us our Themis imagers live from across Canada. And the Themis imagers are filmed. They film the sky in black and white. They are, I think it was originally about 33 of them, and it was Alaska, Yukon, Northwest Territories, Nunavut, Alberta, Saskatchewan, Manitoba, Ontario, Quebec, Newfoundland, Labrador. And now we see one camera in Greenland. It's not currently showing the live feed. But the reason we're keeping an eye on this is this shows us when we do have a geomagnetic storm, all of these cameras, they tell the story of the north-south movement of the auroral oval. And I absolutely love the way that this camera introduces that to us, because they're giving us a sense that while we might have a view above our own sky, if you live in the north, or if you live in northern part of the prairies, you might have that view. You might love that view, but it's part of a bigger view, like a much bigger view, which is the global perspective. And this helps give us the global perspective, particularly on the nightward side. When there's a geomagnetic storm underway, you may, on some occasions, see an arc all the way across the country, and literally before your eyes, you can watch it move south and then erupt with lights all across Canada. And that's kind of what we're hoping for tonight, is one of those bigger events that is the sign of a geomagnetic storm. It's a sign that we have turbulence in Earth's magnetic field, and it's just a great window in real time to what's going on in the Sun-Earth systems, in the Sun-Earth relationships, in geospace, if you will. Okay, so currently not a lot going on across Canada. So why don't we I'm going to take a bit of a break. I'm going to go and get some coffee. Yes, coffee. The drink of champions if you are into aurora viewing. And I'll be back shortly. And we'll do another update at, we'll say, 1 o'clock local time in Yellowknife. I'll be back. All right. You're watching an Astronomy North live event. Our first ever live event, which is totally cool. And it is featuring tonight's geomagnetic storm, or the geomagnetic storm watch that's in effect. We have already had one G2 event. We're watching to see if activity picks up in the coming hours. Stay tuned. There could be more activity. If there is, I will pop right back on the microphone and we can do the play-by-play and watch it in real time. Anyway, keep an eye on the sky. I'll be back shortly. And we're back. That didn't take long. I didn't even get upstairs for a coffee. Check out what's happening right now near Churchill, south of Churchill. You can see it on the camera, the Themis imager for the area just south of Churchill. So if you live in Winnipeg right now, if you live in Thunder Bay, you should be going outside as soon as possible and checking out what's going on in the northern sky. It is looking like there is some activity increasing and an arc that is extending from the southern tip of James Bay over to what looks to be Saskatchewan, as far west as Saskatchewan. And the reason I'm seeing that, like if you see that imager, you can see like almost dead center in the screen there, a rapidly changing these rapidly changing blobs. Those aren't blobs. Those are events that involve light, and the camera is now picking them up, and it looks like it's a very isolated event. It's not connected to anything across the area. Now, what else could be causing that? Like usually we will see a line form across. Sorry if I'm yelling into the microphone. I get excited. Okay, so we're seeing, usually we would see other cameras showing little blips of light or maybe an arc. And if you look to the east of that main camera in the middle, just near Churchill, you can see that there are some increased light events there, but there may be clouds. And so they may not be as intense as what we're seeing in that main camera in Churchill area. So now let's keep an eye on what's happening with the Churchill camera. Let's see if somebody is able to pivot that camera south. I don't have control over that, but they do if they're listening, or if they're able to detect that. Check it out. It may be coming over top of the Churchill camera shortly. So if this camera is facing north or northeast, we're going to keep an eye on it to see if indeed it is showing us the real-time picture. You can see there is increased green. Looks like there's more green in the backdrop behind the bright red light on the tower. If you are anywhere near that tower, please turn off that red light. That would be really, really helpful right now. Okay. So again, what are we seeing there? We're seeing what could be isolated auroral activity, like a substorm event. Local midnight right now is essentially Yellowknife, Saskatchewan, coming towards Yukon would be where midnight is right now. So generally speaking, why is that important? Well, that means if you live in the Yukon, you're looking east right now to see if you can see the northern lights. If you live in the Northwest Territories, you're looking probably south based on what this imager is telling us. It's telling us activity levels are to the south. Activity is increasing to the south. So you're watching for magnetic structures overhead that are pushing south. I'm just going to see if I can pop up the weather. Where's my phone? Okay, I'm going to see if I can pull up the weather for Yellowknife right now and see what we see. And maybe, just maybe, if you live in Yellowknife and you are looking south right now, you may be seeing active northern lights or activity levels increasing. We're not yet seeing it based on the Fort Smith camera. I believe it's a Fort Smith camera in the Northwest Territories, south of Great Slave Lake. We're not seeing that arc yet. I can see a hint of an arc in, I believe it's Dawson. I think that there's a camera near Dawson for this Themis imager, or Haines Junction. No, I don't think it's in Haines Junction. I think it's actually Norman Wells. We don't have a camera in Yukon right now that's working. So I think what we're waiting to see is, do we see the auroral arc extending from near Churchill, where it does appear to be a brighter green? And look overhead now in Churchill. There it is. We can see it happening in real time. I'm going to make bring the Explorer cam front and center now so we can watch this event in real time. This is happening live from Churchill. The camera is not facing south. It must be facing north-northeast. But you can see, based on what's happening on the national scale, that there was something going on in that vicinity near Churchill. And thanks to Themis, these imagers have been able to give us a heads up when there are active northern lights happening somewhere else in the country. So then we can get outside and prepare. So what is this telling us right now? It's telling us that there is increased solar wind speed happening. And the increased solar wind speed is kind of leading to turbulence that's relatively isolated. It's not that the whole structure is shaking, rattling, and rolling right now. It's kind of just an isolated substorm event, is what it suggests. Not a major geomagnetic storm event, but rather, not yet anyway, but rather it's the onset of a substorm, possibly leading to a bigger event shortly. So let's keep an eye on this. Very cool, though, that we got to see this happen in real time. Very cool that you could see it with me. I'm going to see if I can pull up now a couple of the instruments that'll help us understand what is happening here. And so just hold on one sec while I pop open a few more windows and we take another look at some of the data. Let's see if there's any new information here that we're not seeing, or any new information that's going to help us understand what we're seeing. So let's just say we can take off the all right, did I just lose the camera? I hope not. I think I lost the Explorer cam. How do you lose the Explorer cam? Come on, let's go. Where'd it go? Okay. Did the Explorer cam shut off? I hope not. Let me see if I can pull that back up again. In the meantime, I will put the Themis camera back up here so we can watch that together for a sec. And we can see that again, the light show is not it's not a national event at this moment. It's not a coast-to-coast event yet, but we can see indications of isolated auroral activity. And that was just really cool that there was a spike there for Churchill, and we were able to get it on camera. Thanks to the folks at explore.org for their incredible camera there. And the people in Churchill would be really happy right now looking out to see that show. But it looks like it's dissipated. That's how quickly it can come and go. I was planning to go for a coffee, so I would have missed the whole thing. That's great. Okay. I'm going to see if I can pull that camera back up here. Yeah, okay, we're back. We're back with the live Aurora cam from Churchill. It looks like the activity is still there. As you can see, pillars of light. I'll bring this back to where we were. We can see some pillars of light. There we go. Sorry about all the clicking. That's amateur stuff, I know. But let's get this back up here. There we go. Okay, so what are we looking at again? We're looking at a live feed from Churchill, Manitoba, Canada. We also have on the screen a live feed of the entire country. Thanks to the folks at the University of Calgary for setting up the Themis imagers across the country, coast to coast to coast, and they're giving us a sense of what is happening all across the country. And that's important because it gives us a bigger picture. So we have isolated auroras occurring above Churchill right now. If you're outside, if you're awake, go outside right now. There's a light show underway. And it looks like it's overhead, and then it's to the north. This, I believe, is facing northeast. I believe. I don't know for sure. But we just saw auroras on the Themis imager to the south of Churchill, and there was nothing visible on the Churchill camera. So why don't we put those two things together and make the assumption that we are facing north. And I just want to again promote the fact that that camera is manually adjusted. Somebody can actually adjust the direction. And it's perfect direction right now. We're getting some nice pillars of light, and they're slow moving. And that's interesting. Again, on a night where we were predicting I wasn't predicting. I was looking at the data just like everybody else, as NOAA predicted. A G3 strong geomagnetic storm was in the forecast for this evening, with a possibility of a long-duration geomagnetic storm event overnight. Well, we are now officially overnight. It's past midnight in Yellowknife. It's approaching midnight in Whitehorse. We still have not had a major geomagnetic storm event this evening. We have had one today. There was a G2 storm earlier in the day. It was visible above Scandinavia. However, this event, when you look at it from Churchill, it looks amazing. But guess what? This is normal for Churchill. This kind of an event. This is a substorm. An isolated area of turbulence that leads to isolated auroras above this location, above a lot of communities that are located at 67 to 69 degrees north magnetic latitude will have a display like this almost every single night. So that's Yellowknife in the NWT. That's all the surrounding communities in the NWT. Hay River, Fort Providence, Fort Resolution, Lutzel Cay, Norman Wells is going to get shows like this almost every single night. The Northwest Territories communities, there seem to be a lot of communities that are forgotten when we talk about the activity. We always focus on Yellowknife because Yellowknife has a lot of the tourism infrastructure. But if you're just looking from a scientific point of view, a lot of communities in the NWT are in the ideal position for aurora viewing. What about in the Yukon? Well, Dawson is at about the same magnetic latitude as Yellowknife and Churchill. So that means, technically, based on your position magnetically, you are likely to have pretty much the same probability of seeing active auroras almost every single night. So in other words, substorm events like the one we're watching right now, live from Churchill, Manitoba, Canada, occur above Yellowknife. They will occur above Dawson. They will occur just south of Iqaluit. Oh, they're showing a highlight again. That's a highlight from earlier. That is not real time. It's cool, but it's not real time. Just so you know. I believe this may have been earlier tonight. It's hard to know for sure because they don't put a timestamp on that replay. But, hey, cool. Love it. But I'd rather we got back to that live feed because it could help us determine if things are going to be picking up across Canada or not. Okay. So where was I? Oh, yes. So essentially a number of communities across Canada are at the same magnetic latitude. We tend to only talk about Yellowknife and Churchill and other locations, but truthfully, there are quite a few communities. The bottom line, though, is that these are communities that get to enjoy a substorm event almost every single night. And these substorms happen almost every 4 hours or so. So if you live in the north, you're used to this. This is the norm. If you live in southern Canada, you don't see these events nearly as much, nearly as often. And that's primarily because it would take a relatively significant geomagnetic storm or geomagnetic event for that oval to push south and be visible and lead to auroras that are visible above southern Canada. Okay, I think we're back to the live feed for Churchill. We are, because there's that bright red light on the tower. If anyone is listening in Churchill, please turn off the red light on the tower. If you're not able to, there aren't a lot of people, I think, tuned into the first ever Astronomy North live event, so I'm not surprised. But check out what's going on behind those clouds. Isn't that cool? You're seeing pillars of light indicating particles that are pouring along magnetic structures, interacting with oxygen and nitrogen in Earth's upper atmosphere. The green is an indication of electrons, mostly electrons, interacting with oxygen. The intensity there, that brightness, is the result of increased number of layers of light. So you're not just looking at one pillar. Imagine you had stacked 4 or 5 or 6 or 7 or 10 or 1,000 pillars. I can't put that into perspective really, but layers of light that you're looking through create that increased intensity in isolated spots on the structure. And then along the lower edge, we're looking for pinks and purples and that more intense, deep purple color. The crimson, that's the great word. I love that word, crimson. Crimson is an indication of oxygen interacting with nitrogen in Earth's upper atmosphere. And so one of the really important points there is the closer you get to the surface of Earth, the thicker the nitrogen content. So when we look at an aurora, we're seeing auroras. This aurora, for example, these green lights that we see are about, between 100 and 300 kilometers above the surface of the planet, generally speaking. If we were able to pivot this camera and tilt it up, we may be able to see the red auroras that occur at the top of the reddish colors that are at the top of some auroras. I'm looking at the live feed Themis imager, and it looks as though we're starting to see auroras. Sorry to interrupt myself. Looks as though we're starting to see auroras above the Northwest Territories now. So the activity is starting to spread across the country, or across, certainly east to west. I'm just going to pop that Themis imager back on. Oh, I went full screen. Okay, why not? You can see, again, we're not seeing the same auroras above Churchill. So remember earlier we did see a surge in auroral activity in the area around Churchill. I'm wondering if the Explore.org camera is a little bit delayed, maybe. It's possible, because when we see the Themis imagers, they're very close to real time. So when you look at the timestamp there, it's showing 6:55 universal time. On my computer screen, it's showing 11:55 local time. So when I look at the Themis imagers, I'm seeing real-time data, like very, very real time, if that's a thing. So it looks like we have activity occurring across the Northwest Territories right now. If you live in Fort Smith, if you live in the Athabasca region of Alberta, if you live in Hay River, keep an eye out to the south right now. You may have the opportunity to see some active lights underway. And if you live in Yellowknife, you're looking south. You are definitely looking south right now to see if you can watch the arc intensify above the southeastern horizon. You're looking southeast. It looks like there's the same sort of activity. It's an isolated, I'm not going to call it Apache aurora, because Apache aurora is a specific kind, like a specific type of aurora. That's not what this is. These are isolated periods of auroral activity. I guess that's the best way to describe it. So we can see now, again, above northern Alberta, southern NWT, we can see the same isolated little pockets of light that were previously above Churchill, Manitoba. And when we look at the live feed from Churchill, we are still seeing northern lights. We're not seeing them in the Themis imager. So that tells me, it suggests that the Explore.org camera is a little bit behind. And that, something that's logical. Why? Look at the quality of that camera. It may take a while for that data to flow. And so while it is very close to real time, it may not be actually real time, because this is probably a very heavy stream, live stream. as far as the data flow goes. The Aurora Max, sorry, not the Aurora Max. Well, yes, the Aurora Max imager, but the Themis imager, they produce relatively small file sizes per image. And so it doesn't take nearly as long for those images to upload to the server and then be visible to the public in real time. So that's probably why we're seeing a bit of a delay in Churchill, and we're seeing real-time activity above the Northwest Territories thanks to the Themis imagers. Cool. I still haven't gone for that coffee yet. I should do that. Maybe I'll do that. So I'll let you enjoy the light show a bit. If you're still up, we are still waiting for the forecasted G3 geomagnetic storm. It hasn't happened yet. But we'll be back shortly. I'll be back shortly, and we can continue talking about what's going on tonight. Hope you're enjoying the show, and keep an eye on the northern sky no matter where you are. Anything can happen in the next little while. Hey everybody, hey Northern Skywatchers, Skywatchers across Canada. You're watching an Aurora Max live event on YouTube, on our Astronomy North YouTube channel. I'm James Pugsley. I'll be here for a little while tonight, helping you navigate this geomagnetic storm watch. So, a couple of really important things happening right now. We want to acknowledge that there is obviously activity in Churchill right now, but I just stuck my head outside and we can see the northern lights above Whitehorse. A very faint show is starting to occur here, and it looks like it is simply the continuation of the east to west surge that we just saw. So what we're seeing above Churchill right now actually occurred a little while ago. It's not a live feed. It's not as live as the Themis Imager compilation that you're seeing at the National Map of Canada with a series of imagers. And you can see in the Northwest Territories on the imager, you can see this sort of fuzzy gray pocket of light. So the little spots, those spots of light you see, that's the moon. So the imager is capturing the moon in all those cameras, and that's why it looks like there's, high beams on some vehicles across the country. It just happens to be in the same latitude. Well, that's not what it is. It's that the imagers, all of the imagers, are capturing the light of the moon right now. And if it's cloudy, you can see like in southern, down in southern Alberta, no, southern, I think I'm getting tired. In southern Alberta, southern Manitoba, southern Saskatchewan, you can see it's a bit cloudy there, but the moon is still shining behind the clouds. So that camera that's at the bottom of your screen on the array of imagers, that camera is still showing us the sky. It's just the light is not, there's light from the moon that is illuminating the clouds, and therefore it is not a crystal clear night there. Look a little bit further north though. Churchill is the camera, or just further north of there is the camera that would include the skies above Churchill. And it's not showing auroras right now. It's sort of dead center, almost in the on the Themis array. Yet on the left, we can see that there is an aurora visible above Churchill. So the Themis imagers are quite sensitive. So I'm suggesting what's happening there is that the quality of the image we're getting from Churchill it's such a large feed, like the data, the amount of data that is moving through the system is pretty large. So it's taking a while to get that uploaded to the server. Whereas the Themis imager, now we can see, take a look at the Northwest Territories. Right now, you can see a spike or almost like a line, a curve now. It's gone in a bit of a fishhook shape. That's a sign that active lights are happening above the Northwest Territories. And that is very close to Yellowknife, very close to Hay River. So basically, hey, heads up Yellowknife, you're getting a show right now. And it's likely straight up over top of you and to the south. If you live in the Yukon, you are looking southeast right now for the current display. And what you're seeing is the peripheral display of what's happening in the NWT. You're seeing a side view of the show that's going on in the NWT. It's not yet overhead in the Yukon. It's making its way here, though. I live in the Yukon, so that's going to be a show I'm going to be checking for shortly. I'll take my phone out, see if I can snap a few pics and put them on the feed here. Why not? I'm having my coffee now. That's what that sound is. All right, if you're just joining us, you're watching an Astronomy North live event. A geomagnetic storm watch is in effect for planet Earth, and therefore there is a geomagnetic storm watch in effect for Canada tonight. And thankfully, the timing of this prediction, this geomagnetic storm prediction, was perfect for Canada. There was a prediction we were going to reach KP5, KP6, KP7 levels this evening, and a longer duration event was expected overnight. So we were going to be hovering between KP5 and KP7, with the peak happening around now It was actually supposed to be a little bit earlier, but it's usually give or take a few hours. So the prediction was we would have an early event, an early auroral event, and we did. There was a G2 storm earlier today, but it was still daylight in a lot of the locations across Canada. It may have been getting dark enough above Eastern Canada. I haven't checked the social media yet to see if we can find any images from across Canada yet. But anyway, the point being is that earlier today, when the skies were dark above Finland, Sweden, Norway, Russia, that's when the most intense event occurred so far, and that led to a declaration of a G2 storm. It didn't lead to northern lights above the southern half of Canada. It didn't lead to northern lights above the northern part of the United States, as predicted. Not yet, anyway. It is still possible that we could have significant geomagnetic storm activity this evening. I'm going to just pop up the data here. We can take a quick look and see what's happening according to the Space Weather Prediction Center. So that camera we've been watching for the past few hours, is live from Churchill, or very close to live from Churchill. So I'm just going to keep that there for now. And let's pop open a couple of our other very important portals. And so just bear with me here, and I'll pop up the Space Weather Prediction Center website. And we'll take a look and see what the current solar wind speeds are. If you're not familiar with the Space Weather Prediction Center's page, I can give you a bit of an introduction to that here. So for that, I will need to switch our screens a bit. Here we go. Pardon the clicking. Sorry about the clicking. I will get better at this, I promise. You only get one first time ever, and this is my first time ever. So if you're watching, thank you for watching. We're hopefully going to be doing this regularly as solar activity picks up, and therefore hopefully auroral events start to become more common. And by that I mean geomagnetic storm events that are visible across Canada and into the northern United States. And the purpose of these live events is to support a better experience for everyone across Canada and in the north as we wait for geomagnetic storms to occur. So let's take a quick look at where we're at. So according to the Space Weather Prediction Center website, our current solar wind speed is 538 kilometers per second. That is kind of close to what they were predicting would occur when the coronal mass ejection arrived at Earth. Not just one coronal mass ejection, though. There were a number of gusts of solar wind, and they were coming from active region 3078 on the sun. And they kept happening, like they were popping in order, like just one after another. Generally speaking, they weren't perfectly Earth-directed, so the prediction was that we may get a glancing blow, and that glancing blow would lead to turbulence in Earth's magnetic structures, Earth's magnetic field, I should say, and that turbulence would lead to G1, G2, possibly even G3 geomagnetic storms. So let's take a quick look at some of the real-time data. Let's take a look at the real-time solar wind data for right now, and it'll give us a sense of where things are at. Now, interesting, very interesting. Why am I saying that? Well, generally speaking, since I've been on this feed, this live event, we have not had the conditions for strong auroras. I hope it's not something I've said. But you see this, this is I think it's the 2-hour window. So everything that you see here on this data is within the past 2 hours, starting at about 5 o'clock universal time, and it's approaching 7:15 universal time right now, which is 12:15 local time in Whitehorse, 1:15 a.m. if you live in Yellowknife. And interesting, since about 6 o'clock universal time, the magnetic field has literally shut the door on the incoming solar wind. And how do I know this? Well, if you look at the red line under the BZ, BT index up here, the red line, if the red line is above the 0 marker, it means no auroras or very few auroras. It means that the magnetic field of the incoming gust of solar wind or the incoming solar winds in general does not align well with Earth's magnetic field. So we're seeing instead of an attraction, we're seeing resistance, which means that the magnetic field Earth's magnetic field is kind of not allowing the geomagnetic storm to occur right now. Now, that being said, there's no guarantee here that a geomagnetic storm would occur if magnetic fields were aligning. And what's the evidence of that? Take a look at the solar wind speeds. We're not seeing a big spike in solar wind there. Right now, our current situation is 550 kilometers per second. That's kind of what they predicted would be around the max of the solar wind during the peak of this event. So that's good information, first of all. It's not like it's good or bad from an aurora viewing point of view. What is interesting, though, is it's suggesting that there hasn't really been a spike in solar wind speed lately. Anyway, we're looking at a 2-hour window with the real-time solar wind. There hasn't been a spike, which suggests that it's not an ambient solar wind. It's not the normal solar wind, which is hovering around 300 to 400 kilometers per second, sometimes a little bit lower, sometimes a little bit higher. This is actually telling us that there is increased solar wind speed. Maybe the plasma density isn't what was expected. So plasma density. So if you look at this line, the orange line, I shouldn't say anything before. I should look at the graph first and then talk. Make a note to self. So plasma density is relatively high right now, 10.24. That plasma density is referring to proton density, I should say. So it's the number of protons per cubic centimeter. Is that right? I think I got that right. I'm sipping some coffee here. Please hold. Okay. So 10.24, that's actually pretty high proton density. So they may be seeing, of course, this may tell us that they were right in their predictions, but wrong. Right in the predictions that there was a dense cloud of plasma on its way, but maybe wrong that it would have a turbulent effect on Earth's magnetic field. So I'm now going to the WSA Enlil Solar Wind Prediction Model, which gives us a sense of CME arrival time. So coronal mass ejection is a gust of solar wind, and that gust of solar wind can take anywhere from 2 to 4 days to reach Earth. And what we're seeing here in the pinwheel in the top of the screen is, with the sun at the center of that disk, we're seeing these waves, these bursts launched out towards those 3 dots. Those 3 dots, 2 of them are satellites, 1 is Earth. The one in the middle is Earth. The green one is Earth. And the plot on the side, the right-hand side, it's trying to plot what we're seeing on the visual on the left. And that shows a spike in plasma density in the top and a spike in solar wind speed at the bottom. The radial velocity is called there. And so those 2 factors, plus the fact that there were multiple bursts heading towards Earth, would be the reason why NOAA made the prediction that they did. And that doesn't necessarily guarantee anything when they make these predictions. The little imager, this sort of cone, I don't know, what do we call that? What's the name of that shape? Cheese. Okay. This little cheese slice, I don't know if that's right, is showing us actually the side view of the same event. And what does it tell us? It tells us if the incoming gust of solar wind that we can see from above is going to directly hit us or be above or below, in other words, north or south, if we wanted to use those terms, of the plane of the solar system, or essentially north or south of Earth. Will it miss us or will it hit us? Is kind of what that's trying to tell us. And based on this prediction, it's showing that we would get hit by a portion of that dense cloud early on the 18th universal time. Well, where are we right now? We're no longer at early on the 18th on universal time. We're a little bit later than that. So whatever was expected to happen should have happened by now if we were just believing what we see from NOAA. But there are other prediction models out there. So NASA has a different model, slightly different. They predicted that the big event was going to happen later today. And so that's cool. What does that mean? That really means that there is a plus or minus, 6 to 8 hours in the measurement of their accuracy around the prediction. They can sometimes be off 6 hours one way, 6 hours another way. So we get our hopes up. That's the problem here. We get our hopes up because we see these predictions as sky watchers. It's exciting because you have an increased probability of seeing auroras. But that's not what they're saying. They tend to say that there's a watch. A G3 storm watch gets the media's attention. The media then will say, hey, it's going to be a great night for Northern Lights. Get out there. When in fact, the story should be there is an increased probability if conditions are right. But guess what? That's not very sexy. That's not the kind of news story that makes its rounds in the papers and on social media. So generally speaking, we definitely appreciate the incredible work they're doing at the Space Weather Prediction Center. But ladies and gentlemen, we need to just sort of be mindful that they aren't always right. And in fact, when I put together the aurora forecast for astronomynorth.com, I tend to lean a bit more conservative than some of the predictions we see from NOAA. NOAA, I think, leans a bit more towards the optimal or the most significant event in their announcements, because they'd rather industry knew about those possible G3 levels so that those industry partners could, the industries that they serve, which would be the aviation industry, communications industry, the military, that those stakeholders would know there's a possibility of a G3 storm is very important. If instrumentation gets damaged or is scrambled as a result, hey, that's why they're doing their job. But from an aurora viewing point of view, it's frustrating because you would go outside, you set up your cameras, and you're not seeing much. And you're thinking, holy smokes, I was told it was going to be glorious tonight, and it's not. And then you go to bed, and then the lights come out. That's usually how it goes. Anyway, the point being is we are still not at G3 levels right now. In fact, the predictions were solar wind speeds would reach around 550, and they are there right now. Based on this model, they got it right. The predictions were that the density of the particles would be hovering from 10 all the way up to almost 25, 30, well, I'll say 25. Yeah, 25 particles per, what is that we're saying? Yeah, well, I'm not able to interpret what this sideways r squared n centimeters cubed. So let's just take it into account that it would be I believe it's number of protons per cubic centimeter. I could be wrong about that, but anyway, I will look into that. Anyway, the point being is they don't seem to be wrong about the data as it's showing. The current data is consistent with what the predictions were. What they may have unfortunately succumbed to is that the Earth's magnetic field is currently, the polarity of Earth's magnetic field is currently resisting the incoming solar wind. So we're not seeing a spike in that red line on the ACE data, the real-time solar wind data. We're not seeing that spike that suggests auroras are about to be intensifying. So that's what the data is telling us. It's telling us we are still waiting for a G2, G1, or G3 event. We're not there at this moment. Could happen at any time. And instead, we're going to be celebrating the fact that we do still have some auroras across the north. And that includes Churchill. Let's take another quick look at how things are going at Churchill. Live feed. Relatively close to being the live feed anyway. Thanks to Explore.org's contribution to having this incredible camera. Again, you should go to Explore.org to watch this camera and so many other cameras in real time. But I am a huge fan of this camera because of the quality of the image. And again, I believe because of that quality, it's not actually showing us real time. It's showing us a bit of a delay. I could be wrong, but if the imagers on the left are not showing auroras, chances are there are no auroras there. So that image that we're seeing right now is likely, I can kind of see, to be honest, I can kind of see some auroras in the Themis imager right now. I think I see auroras. I'm just going to increase the size of that shortly here. Or I'm going to increase the size. I'm just adding words at this point. It's good to have fun. Okay, let me just put this, the Churchill imager in another location. There we go, I just swapped them. Yeah, I thought I was seeing some auroras above Hudson's Bay, sorry. It may just be cloud cover. Yeah. I think I see a faint arc right now, also above western part of Northwest Territories, and that may be what we're seeing above the Yukon right now. Is looking east, southeast. We can see some faint pillars of light. And if you're just joining us, we're monitoring the current situation across Canada with an Astronomy North live event dedicated to tonight's geomagnetic storm event. The prediction was a G1 to G3 geomagnetic storm. G3 is a strong storm, and they're not that common. G2 is a moderate storm. They're certainly more common. And a G1 is a minor geomagnetic storm. So that is definitely common, I'd say. Especially as we're starting to head towards the peak of the solar cycle. We're coming out of solar minimum, which was December 2019, when we saw the polarity of sunspot activity, polarity of the magnetic structures near sunspots change. They flip. And that was what indicated we were in the new solar cycle 25. And so now it's 2022, August the 18th, 2022, and we're starting to see the sun come alive. And it really came alive this week with multiple coronal mass ejections, Earth-directed coronal mass ejections, no less. So it's one thing if you have an explosion on the sun. It's another if it's an explosion on the sun that's aimed at Earth. That's a big factor for aurora viewing. So we don't just watch the sun for sunspots, coronal holes, or filament eruptions. We're watching to see if those events are occurring in an area that is Earth-directed. And there are some areas on the sun which we want to particularly pay attention to because they tell us if something is going to be launched towards Earth. The experts at NOAA and the Space Weather Prediction Center, they're the ones that can tell us, based on looking at some pretty cool instruments, whether or not the eruption is indeed heading towards Earth, or will it miss us to the north? Will it miss us to the south, to the east, to the west? Which is funny terminology to use when you're thinking about space, because how do you know which is north and which is south when you're in space? Anyway, that's a whole different issue. So the prediction was there'd be a up to a G3 event tonight. We have not yet seen that event. We are seeing some activity above Churchill. And the reason we don't have a lot of other cameras on the feed tonight is that they're not on yet. The Aurora Max Imager will be on in the next couple of weeks. A crew is going into Yellowknife to get the observatory ready to kickstart the season, and so that's going to be exciting. Astronomy North, the University of Calgary, the City of Yellowknife, and the Canadian Space Agency are partners in Aurora Max and have been for 12, 13 years now. And it's been an honor to be partners with these groups, because we're all working together around one thing: is how do we help connect more and more people to Canada's northern sky, and how can we use this opportunity to learn more about what's happening at 68 degrees north magnetic latitude, a great place, a great viewing location on the planet, not just from a climate point of view, or not just from a location because there's a Tim Hortons there. I mean magnetically. Sorry if I just plugged Tim Hortons. So nobody's paying me for this. This coffee is not from Tim Hortons. So there, I'll just say it that way. Anyway, the point being is the magnetic latitude of Yellowknife at 68 degrees north magnetic latitude is talking not about its geographic latitude. It's talking about its proximity to the north magnetic pole, which is different than proximity to the North Pole. So any community that has the same magnetic latitude as Yellowknife chances are going to have pretty much the same opportunity to see northern lights almost every single night. And guess what? Churchill is extremely well positioned, just I think around 67, 68 north magnetic latitude. Dawson and Yukon, pretty much the same magnetic latitude. Iqaluit is a little bit further north, I believe, than Yellowknife and Churchill magnetically. But again, great shows almost every single night. What you need, of course, are clear skies, dark skies, and we need to make sure we're not just looking at our phones, that we're actually looking up in order to see that show. I'm watching the Themis imagers right now, and you can see an isolated pocket of auroras occurring above Hay River. And so if you live in Fort Smith, Hay River, Fort Resolution, Fort Providence, get outside right now. It's happening right now. If you're still up and you're watching for the show, this is the moment. Get your cameras ready. If you're in Yellowknife, you're seeing this as well. It's above the southern horizon in Yellowknife. We don't have a camera there right now. It'll be on in a few weeks to capture that event and give you an even more detailed look at what's happening above the Northwest Territories right now. This is so cool. You're listening, you're watching an Astronomy North live event. I'm James Pugsley. I'm the president of Astronomy North, and I'm a volunteer here to support your experience as this geomagnetic storm event unfolds. And if you have any questions you want to submit, go on to YouTube. You're probably watching this on YouTube Live, so you don't have to go there. You're already there. But send in your questions. Put them in the comments section. Or you can message me through YouTube. Or you can go on our Twitter feed. And tell us what your questions are. Let us know what your experiences are tonight. Let's see if we can help you see the lights tonight. Could happen now. Could happen in the next few hours. All right. So again, I can see there is some auroral activity going on in the Northwest Territories right now. On the left, we're seeing the images from Churchill. On the right, we're seeing a coast-to-coast array of cameras, thanks to the team at the University of Calgary, University of Berkeley, California, NASA, and the Canadian Space Agency. They've set up this incredible project, the Themis project. Not enough folks are really aware of this project. It's primarily because, these cameras are black and white. And I think a lot of folks, when they look at these images, they don't quite know exactly what they're seeing. But I'll just say, with regards to imagers, like, these cameras are really, really providing valuable data to support our understanding of Earth's magnetic field. And if we take away the fact that they're not in color, and we just look at them through the lens of coast-to-coast understanding of auroral activity, When we see a geomagnetic storm underway, we can actually see an arc form across the country, east to west. And that arc, once things intensify, that arc will push south, and then there's the great release of energy, this great release of a geomagnetic storm onset that leads to beautiful skies and lots of photography. Lots and lots of images posted on social media, and we basically know the moment that people are out taking those pictures by monitoring these cameras. So what are we seeing right now? Well, if you're looking at this imager, the imagers are the circles. So some of the circles, though, are currently either not on or they're having technical difficulties. So the blue circles represent cameras that currently aren't on or currently are having technical difficulties. The dark circles are showing the all sky image for that location. So I think we have Rabbit Lake, Saskatchewan. I think I got that right. We have, I think, around near Churchill. We have a camera in Fort Smith on this array, and I'll for our next broadcast I'll have more details, because I think that to be honest, I think that this is going to be the most helpful tool for supporting your Northern Lights experience, along with learning about all the data and understanding the weather and the timing and all of that. It's hard to do all of this all at the same time, though. That's what I'm learning right now. There's a lot of talking going on. A lot of talking, but it's pretty cool stuff. So hopefully you're enjoying it. All right, we're coming up on, it says 12:37 local time in Whitehorse. I'm going to go take a peek outside and see what I can see, because I just saw that activity above the NWT. I'm guessing we're going to be seeing some above the Yukon shortly, and the cameras in the Yukon are currently not on. So I'm going to go and turn on my camera and see if I can see anything. So I'll be right back. I'll leave these imagers running, and I'll give you an update shortly. Hey everyone, so the latest from Yukon right now is that look, I was just outside in Whitehorse and we did not see a lot of activity. There is a faint arc. It looks like it's the same structure that is currently visible on the imagers on the right. The array of Themis imagers there, we can see that there is a faint arc near in the Northwest Territories right now, very faint. That same arc is visible now above the Yukon. All right, so we have not seen a lot of activity above the Yukon. And so what is this telling us? Well, we are still seeing some activity right now. We're seeing activity, these periods of activity. We saw them earlier above Churchill. The Churchill camera is on the left. And on the right, you see the array of cameras. The array of cameras from University of Calgary and University of Berkeley, California, and the Canadian Space Agency and NASA that have come together to support the Themis project. And the Themis imagers are showing us a coast-to-coast view of what's happening in real time across Canada. It's the perfect tool for talking about a geomagnetic storm or a geomagnetic event like this because it gives us a sense of whether or not anything is happening right now and whether I should be talking about the auroras in real time or should we talk about the data that is giving us an idea of what could happen. So I'm looking at it right now. On the left, we see, again, the camera from Churchill. The bright red light on the tower has been on most of this broadcast. I think actually on for the duration of this broadcast. But every now and again, they pop up a highlight video. And I think the highlight video was from earlier tonight. I'm not 100% sure of that, but it was a highlight that shows active auroras and the light is off on the tower. But just it's such a great camera. Live from Churchill, Manitoba. We don't have the Aurora Max camera on yet. It'll be on in the coming weeks. And the 13th season will get underway. And that will be a great camera to have on this broadcast because it can show you, again, in real time, what's happening in the skies above Yellowknife, Northwest Territories, Canada. Furthermore, we can complement it with other cameras and look at what's going on in different locations across the country. And the whole hope here is to give everyone a bit of a heads up. Give you a sense that now is the time to go out. Now. No, you get the idea. When the time is right, we'll let you know. And in the meantime, it's a good opportunity for sky watchers, space weather enthusiasts, people who are into ham radio, people who are into studying the sun, students, anyone, media. Welcome to the media who are going to be up at the wee hours of the morning to see what's going on as far as auroral activity. So the whole idea here is to get more and more of us connected to these geomagnetic storm events because these are the big shows. The big shows, the big chance for you in southern Canada and northern United States to see the aurora. And what a great opportunity to learn about what is causing these events and why do we see what we see. I'm James Pugsley, by the way, if you didn't know who was talking right now. I'm the president of Astronomy North. I've been an aurora forecaster for a long time, almost almost 20 years now for astronomynorth.com. And we provide an aurora forecast for northern communities. And that's it's not that difficult of a job. It's not a question of whether or not there's going to be an aurora. It's more a question of like, what kind of a night will it be? Will it be a night of active auroras? Will it be quiet? That sort of thing. So we do those predictions based on the information that's provided or available on the Space Weather Prediction Center website, Space Weather Live, spaceweather.com. There are lots of great websites out there, lots of different perspectives of what's going on, both on the sun and in the near-Earth environment or geospace. And so my role is just to help put forward a forecast based on the magnetic latitude of northern communities. What do the current global or the predicted global conditions mean for the skies above your community? It's lots of fun. So that being said, I'm here tonight to just help you navigate this geomagnetic storm. And this is the first ever live event. First ever Astronomy North live event. And I have no idea how long these events are going to go. You know, maybe we'll have, a major major coronal mass ejection, like gust of solar wind heading towards Earth. And it'll be arriving midday. And that midday arrival means that we could have active auroras early in the evening, right after sunset. So maybe these broadcasts will be, really popular when they're earlier in the day. But the overnight feeds are going to support anyone who is, particularly if you live in Western Canada. I think these overnight feeds are probably going to be helpful for you. Because a lot of times, I've seen this many times, is we have an alert issued that says the auroras are going to be visible and incredible above Canada. And then the storm will hit, the geomagnetic storm event will occur above Newfoundland, Labrador, and then fizzle out. And yet here we are in Western Canada, and it's still daylight here. The sun goes down, everybody goes outside looking for auroras. Well, guess what? The storm's already passed. So my hope is that this forum, this represents an opportunity to try and help everyone understand what we're seeing, why we're seeing it, and more importantly, understand that this is really still a mystery. A lot of this stuff is still a mystery. Scientists can predict a lot of things, but whether or not there's going to be an aurora tonight is still a mystery. Primarily because of magnetic fields. We won't know the magnetic polarity of the incoming solar wind until it arrives at Earth's magnetic field. We won't know if they will line up beautifully or if they will resist each other. And that's a major factor. So, first factor is there activity on the sun? Yes or no? Is that activity Earth-directed? Yes or no? Okay, if it is Earth-directed, is it an intense event that is going to be a direct hit? A glancing blow? Will it miss the Earth entirely? Okay, well, let's imagine it's going to be a direct hit. Great. That's still not a guarantee that there will be active northern lights. That's just hinting at the fact that there's an increased probability, a significant probability, if it's a major incoming gust of solar wind, major probability, significant probability, but not a guarantee that the magnetic field of the incoming solar wind is going to line up beautifully with Earth's magnetic field. Think of the bar magnets. If you have a north and a south on a bar magnet, they come together. That's what we're hoping for. The Earth's magnetic field has a polarity that is largely tilted north. And if an incoming gust of solar wind has the same polarity, well then we may not have an event at all. Or it'll just be a mild event. But imagine now let's imagine that it is, again, an incoming gust aimed directly at Earth. It arrives at the magnetic field and the polarities line up. Well, guess what? That's good news. That means auroras. But that's no guarantee of auroras above Canada. that's a guarantee of auroras on Earth. Maybe. How can you say that? Guaranteed maybe. It's a guaranteed maybe. It could mean that there's a short duration event. It could mean that there's a long duration event. It could mean that there are multiple events over multiple hours. There's just a lot we just don't know. And that scientists are doing an amazing job to bring all the pieces together and get more and more of an understanding of the Earth's ionosphere, more and more of an understanding of Earth's magnetosphere, more and more of an understanding of the sun and the solar wind. And we're getting there. We're definitely getting there. But I just want to say that these cameras that we're looking at right now are telling us that there is not a geomagnetic storm underway. They're telling us that the normal auroral conditions, the normal conditions and the normal auroras are underway. I don't want to describe an aurora as normal, but this is the norm for the north. So Churchill is seeing auroras. We can see it on the camera right now. These are not visible on the... I can kind of see an arc, to be honest with you. I can kind of see an arc on the Themis imagers to the northwest, which is the direction that this camera is facing. I don't know if you guys can see that or not. Let me see if I can... I'm going to close this imager down a bit. Oops, I just closed the wrong one. If you look closely at the Themis imager for the area around Churchill, you can kind of see a very faint arc above Hudson's Bay right now. So that, I think that's what we're seeing when we see this arc on the Churchill cam. We're seeing the same arc, very faint arc on the Themis imagers for Hudson's Bay, above Hudson's Bay. Very cool. Okay, let's take a look at current conditions. Current conditions are showing us that the solar wind speed is now up to 579 kilometers per second. Maybe I'll switch the two, so I'll put this on the main screen and bring the Aurora Max, sorry, not the Aurora Max camera, the Themis imagers. We'll bring them down to the side, and we'll move the Space Weather Prediction Center data over to the main area. Sorry about the clicking. I hate the clicking. All right, here we go. And there we are. So now we're looking at Space Weather Prediction Center data. And the current situation is that the solar wind speed is around 580 kilometers per second right now. Let's go and check out. We'll go to products and data. I want you guys to sort of learn how to do all of this yourself as well. Why not? Let's look at the real-time solar wind. Interesting stuff. It's always interesting when you come to this page because it's telling you in some ways what has just happened, like literally moments ago. A satellite out in space is capturing this data. It's at a point, I believe it's the Lagrange point, which is an area where the gravity of the sun and the gravity of Earth are pulling equally on this satellite. So in other words, it will not lose its spot in orbit. And it is located directly between the Earth and the sun. Not at the halfway point, though, at the Lagrange point, which is, again, where that gravity tugs in both directions. Or I guess there's no one gravity force pulling that satellite away. So it stays in it stays in one locked-in location. There, I figured that out. I figured out how to use those words. Okay, so what's it telling us, though? It's basically like a buoy in the ocean. So as incoming space weather, as incoming solar winds are heading towards Earth, this is our early warning detection system. It gives us an idea of what's going on with the solar wind speed. It gives us an idea of the density of the solar wind. And on the right-hand side is the current or the last known reading from the satellite. You'll see a gap. There's always that little gap there on the far right, but essentially the last known reading tells us that there's no aurora going on. On the top, we see the BZ. It's referring to the tilt of, or I guess we'll just say the magnetic field's polarity and how it's behaving. I'm hoping I'm describing that correctly here. If the red line that you see there is above the 0 marker, it means basically no auroras are going on. When the red line dips below the 0 marker, it means that the tilt has tilted south enough that we're going to start to see particles flowing in. And we did see a bit of a spike there. So look at that. Around the time we were seeing live footage from Churchill, and we saw it above Fort Smith and other areas, there was a spike. It's good data. A spike down. That spike down is important. It gives us a sense of whether or not there's an aurora about to happen. In a nutshell, if we see a major spike where the white line and the red line both spike in opposite directions, that's what we're kind of looking for when a coronal mass ejection arrives and it leads to this, really intense interaction with Earth's magnetic field. That's what we're looking for. Oh, I needed some coffee there. Okay, good. So when that occurs, we basically have about 45 minutes to get outside, get the camera set up, and take as many pictures as possible of what potentially is a colorful aurora, because it's so intense. It's so intense that you see the illumination of oxygen and nitrogen molecules, oxygen atoms, and you see intense crimson along the lower edge of an aurora. You'll see all different colors that you don't normally see if it's just a gentle aurora. Gentle auroras occur, those quieter auroras tend to occur between 100 and about 300 kilometers above the surface of the planet. The more intense auroras will push down to the 80-kilometer mark. I think I've seen a lot of literature that says 80 kilometers. And that the closer you get to the surface of the planet, the thicker the nitrogen content. So that means that those particles are going to be interacting with nitrogen, and that leads to the colors we see along the lower edge, which can be intense pinks, purples, crimson. Cool, very cool stuff. Indication of significantly increased intensity as those particles pour into the upper atmosphere. Anyway, so where I was going with that was what we're looking at right now is an indication that there isn't a lot going on. Particle density has been pretty steady. We have not seen a spike over the past 2 hours at all. And the solar wind speeds. We're not seeing a big spike, but we are seeing that it is around what they predicted it would be. 577 kilometers per second is elevated. Significantly elevated from what is arguably the normal speed for an ambient solar wind is between 200 and 300 kilometers per second. And so tonight we are seeing an increased solar wind speed. We're not seeing the density that was, I think, predicted. So let me just adjust our graph here, our chart, to reflect the past 24 hours. And let's see what story it tells us. Puts things into perspective. Look at the intensity of the event that occurred about a day ago. Is that right? No, sorry, this whole thing is a day. Get it right. That's one day. So you can see that this morning, the prediction was on August the 18th, early on August the 18th, Universal Time, that there would be a possible G3 geomagnetic storm. That was the prediction. So when we look at this current scenario, what are we seeing? We're seeing that about 2003. So that is for, let's, come on, math. Come on, brain. What time is it? Let's look at the time right now. 7:58. So I think Whitehorse is 7 hours difference from Universal Time. Because it's 12:58 here. Yes. It's actually 1:04 a.m. here, so it's a bit off. This the 7:59. Okay, so anyway, so if we were to look at a 7-hour difference at around, let's say about 3 o'clock this afternoon, between 2 and 3 o'clock local time in Whitehorse, 3 and 4 o'clock in Yellowknife, there was a significant tilting of the magnetic structure. And therefore, we had a really intense auroral event. Likely, anyway, if it was dark skies. So where was it dark? It was dark above Scandinavia at that point. And they got to see a show. I'm assuming they got to see a show. Still haven't checked the Twitter feeds to see what they saw. I'm going to do that right now. But anyway, the point being is things have kind of settled down a bit. And we are not seeing that really intense geomagnetic storm. And so they predicted a G1 to G3 event. They were right, but the media just sort of picked up on the fact that it would be a G3. And a lot of folks focus on the G3 part, not knowing that NOAA only predicted the G3 for a short period of time. It was largely going to be a G2 or a G1 event tonight. And we're not even seeing that. Why? Because we're not seeing a lot of southward tilting of Earth's magnetic structure, the polarity of Earth's magnetic structure. And that's okay. It doesn't mean it can't still happen. But what it's telling us is that this is not going to be the big show that they were calling for if we were to just look at this data now. The timing was a bit off, I guess is the best way to put it. But guess what? That is what it's all about. Their probability of success is, if we're only going to be focusing on a storm happening at a very specific time, that's not fair. There is actually a window of plus or minus 6 hours on all these predictions. But you never hear about that. So anyway, we could still have activity increasing over the next few hours. Furthermore, there was a prediction, and I'll go to that prediction now. So we'll go to the 3-day forecast. Here we take a look at the predictions. So the August 18th prediction was G2 storm event between 0 and 3 o'clock UT. From 3 until 6 UT, it was going up to 7. But it was just for that one period of time. And we did not achieve a 7 or a G3. KP7 is the equivalent of a G3 geomagnetic storm. We did not reach G3 levels at that time. And where are we right now? We are in this area. So their prediction was a G2 right now. Well, we're not even at a G1. We're really quiet right now. How do we know that? Well, you can actually just look at some of the data, or look at this tool here. It's not showing it properly, I guess. We'll just go back to the home page. The latest observed shows no geomagnetic storm underway, and that's logical. It shows a G2 has occurred over the past 24 hours, and that there is a prediction still of a G3, but that's just because it was predicted on the 18th that there'd be a G3. Well, guess what? We've actually passed the window, the precise window that they predicted. Doesn't mean we passed the full window. So my guess is by the morning, they may adjust this to be a bit of a dud on the G3. They may just refine their prediction. And that's normal, and that's okay. They're not making these predictions to make Aurora watchers happy. They're making these predictions to let industry know of what could happen. So no problem there whatsoever. There is a prediction of a G2 tomorrow night, or later tonight, I guess. So that's always interesting when you see another G2, a subsequent G2. That means that their prediction is based on potentially the continuing effects from tonight. That's possibly what that G2 is related to. Or they're predicting that there is more solar wind activity expected to arrive at Earth. But when I look at the data, when you look at the, where is it? There. This is their prediction for the current situation. And yeah, it's not suggesting that there's going to be another impact on the 19th. So it really does suggest that they may modify the G2 because the G3, if the G3 doesn't happen. Always interesting to analyze and then overanalyze what the Space Weather Prediction Center is up to. Anyway, kudos to the team there. Of course, they're doing an amazing job to try and interpret a ton of data. Deserve a lot of credit for helping us all learn about what's going on in the Sun-Earth system. Okay, so our current situation is we have no geomagnetic storm underway. We do not see a lot of activity across the country. Is this it? Is this the time when we say, you know what, maybe we call it a night? Is that what we should do here? Well, maybe not. Maybe we'll just hold on a little bit longer. It is 1 a.m. local time in Whitehorse. And I want to keep an eye on a couple of things before we say, you know, it's not happening. One of the things that I'm going to take a look at is the 30-minute aurora forecast. And see what it's telling us right now. Because if it suggests that there's an increased intensity, that's based on real-time solar wind data. So we would have seen the real-time solar wind data suggesting that activity levels are about to increase. So let's watch the past 24 hours of geomagnetic field conditions, with the green not indicating auroras. It's just indicating probability of auroras. And you can see at that moment, that was that moment we were talking about a moment ago. How many times did I use the word moment there? That was the moment when the activity levels reached G2 level. So it was a G2 storm above Scandinavia, Iceland, Greenland got the best view. Wasn't yet dark enough above Canada. Maybe, just maybe, there were some active skies above Eastern Canada right here, but it's still daytime. Yeah. So by the time it was nightfall, the show was over. That show was over anyway. So that's been the peak so far. The past 24 hours was around, what do we say, 20. It's about 8 o'clock Universal Time. And depending on where you are in Canada, that would have been, anywhere from, 3 o'clock to, is that right? It would have been 1, 2, 3, 4 o'clock, depending on where you were located in the country. But 7 hours difference to Whitehorse, 6 hours to Yellowknife Universal Time. And so we have the largest landmass under the auroral oval of any country on the planet. But that's no guarantee we're seeing auroras whenever there's a geomagnetic storm. We still have to have nightfall. We still have to have clear skies. And you still have to be looking up. That's a really important factor if you want to see an aurora. You got to look up. You can't look on your cameras. Don't even look at the YouTube channel. Listen to the voice if you want to, but you got to look up. Okay, I'm going to take a bit of a pause. I'm going to check the social media feeds, see what's happening, and I'll be back shortly. Okay, we're back. Little bit of a pause. We're going to wind down our broadcast today. It looks like our activity levels are sort of flatlining a bit. Not a lot, but a bit, which suggests that maybe it's a good time for us to press pause on the live feed. I don't know. I did do a bit of a search on social media here just to see what's happening. Not a lot of activity across the country right now. Post from Hugo Sanchez. Sky is dancing in Gibbons, Alberta, August 18th. Posted 20 minutes ago. There's a few posts from Scandinavia today. Nice shots from Scandinavia. Not a lot going on. And so I'm kind of seeing, here we go. Yeah, so there's a couple of posts from Alaska. So Alaska is seeing lights right now, most likely similar to what we're seeing out of Churchill. If you're just tuning in, you're watching the Astronomy North live event for the Geomagnetic Storm Watch for Earth, planet Earth, as that ultimately means we have a Geomagnetic Storm Watch for Northern Canada, Alaska, Canada, Southern Canada, and Northern United States. But it looks like we're not seeing the big storm event that was predicted, which would be a G3 storm event, which is a pretty significant storm. It's a G3 is a strong storm in the classification of storm events. And so what we've learned so far is that there was an impact. Multiple CMEs have likely impacted and passed or are currently sweeping past Earth's magnetic field. I will pull up a couple of different media sources for you if you're curious about where to go for more information about tonight's event. There are a couple of good sources available for you here. So let's check out spaceweather.com. It's a good site, excellent site. And spaceweather.com shows you current solar wind speeds in the top left-hand corner, current proton density. So we're seeing, again, 545. This is what I was talking about. We're not seeing a trend upwards anymore. We're kind of seeing a bit of a trend downwards in solar wind speeds. It was at 570 a little while ago. Proton densities have been hovering around 10 most of the night. And so that's suggesting to us that we're kind of in a sort of a stagnant or flatlining situation right now. And so let's just look to that. One of the great things about this site is it's led by a scientist who's been studying the topic of space weather his whole career, Tony Phillips. And I'm not sure if Tony has other members of his team that are helping out here, but he writes a blurb at the top of spaceweather.com every day. And he's been unbelievably consistent in providing information. So it's a great place to go to just check out what's going on. And he's sort of suggesting that in this one, he's just actually talking about the fact that this is likely to continue through the 18th and 19th. And he's still promoting the idea that there could be naked eye auroras visible above the northern part of the United States. The data doesn't suggest that right now, Tony, but maybe over the next little while, we'll see an increase in that activity. Lots of good photos, lots of good information. He's extremely well connected in this field and pulls up lots of good information for you to go check out. He does also know his stuff regarding incoming CMEs and space weather predictions. So very good website, spaceweather.com, if you didn't already know. One thing I noticed down here, this prediction right here is saying at high latitudes we can expect severe storming over the next 24 hours. 90%. It doesn't say 90% very often. In fact, I'm not sure if I've ever seen it at 90%. That's a heck of a suggestion, considering that I don't actually think we were ever really going, like the probability of that G3 was relatively low, to be honest. I think NOAA went a bit on the optimal side of things. Like, I think they sort of had the scenario where they believed that this was happening for sure. And I mean, I shouldn't say it that way. They didn't know it was happening for sure. That's not fair. I think that they looked at the scenario and said that it's very possible that we could have a G3 storm if conditions are right. And it just turns out that conditions have not been right. Therefore, when you see spaceweather.com, some of their predictions align to NOAA's predictions. So it's sometimes a grain of salt with all of that. But overall, a great website. We'll just check on what's going on in Churchill again. Not much. Not much going on in Churchill right now. Okay. Just going to pull up another helpful website, Space Weather Live. Oops, here we go. This has become an elite website in the world of space weather. It's an elite website to be familiar with. It gives you a really good sense of all sorts of data, the solar wind data, the geomagnetic field data, and it can give you a real sense of what's happening and what could happen. So when I think about what was supposed to happen tonight, we were supposed to already be, in the midst of a major geomagnetic storm event. We're not seeing that right now. We're just not. The data doesn't support that, not yet. And we can see that the KP index, the current KP, is 2. Well, what is a geomagnetic storm? Geomagnetic storm is KP 5. And so we're well below storm levels at this moment. But look at there's that 90% again. 90% is predicted that there will be a severe storm on the 18th of August. Some point during the 24 hours universal time. And so let's see if they have to modify that prediction. How soon will they have to modify that prediction? Because the earlier predictions were that there would be an early arrival of a coronal mass ejection. Well, we did see one CME arrive relatively early, which was in the afternoon local time in Canada and the US. But the original NOAA prediction was that right around between 3 and 6 universal time, 3 and 6 a.m. local universal time, that's when we would see a possible G3 storm, KP7. We've actually passed that time. So now we're waiting to see if they are going to meet their target within the plus or minus 6 hour model within that time frame. We're just keeping an eye on that. So if you're just joining us, you're watching an Astronomy North live event. We're keeping an eye on the geomagnetic storm that was predicted for tonight, primarily because it was supposed to be and could still be a very significant geomagnetic event. We have not yet seen data that suggests it's happening in the next little while. And for that reason, we may be cutting the live event here off at around, it's 1:30 a.m. local time, 4:30 in the morning Eastern time in Canada. And so we're kind of running out of that opportunity for most Canadians to see active northern lights tonight. this morning. I'll hang on for a little bit longer. I was just on social media, not a lot of traffic on social media, not a lot of photos so far. A couple posted from Alaska, a couple posted from Alberta. And my guess is we'll see some more when people are when people are opening their eyes in the morning. Vocabulary tends to fade around, what I'm seeing is around 1 o'clock now. Vocabulary disappears. We start going down to single syllable words. So my guess is we'll see more photos tomorrow, but we are not going to be seeing photos of an epic event that was visible from the United States and southern Canada. What we're seeing would be arguably the standard auroras that were visible above northern Canada that would have been visible regardless of whether there's a geomagnetic storm underway or not. We get these auroras almost every single night above northern Canada. And so when I see these conditions, even at a KP2, KP3, those are conditions that are not favorable for active auroras being visible above southern Canada and northern United States, but they are certainly favorable for observers in northern Canada and Alaska who get to enjoy a light show, a substorm, a period of increased magnetic field turbulence that leads to activity levels increasing, auroral activity levels increasing, I should say. And that's what when we see photographs from northern Canada, we see largely these nightly events, these nightly substorm events. And they are beautiful. Okay, so I'm looking at the Themis imager on the left-hand side of the screen there. And if you're just joining us, we have two cameras. We have a couple of cameras in view right now. So on the right-hand side is the camera from Churchill, live from Churchill, with some faint auroras to the northeast. You can see that. But guess what else we can see? We can start to see the sun coming up. That's what that is on the horizon. Is that right? Does that make sense? I guess so. Yeah, that's the sign that day is coming. So how do we know that? Well, look at the imagers on the left. So there's an array of imagers, and pretty much all of the cameras that are east of Churchill are now offline. Yeah, so that's what we're seeing right now. We're seeing the coming of the day. And so we have a limited time frame now for auroras to be visible above Churchill. We're rooting for you, Churchill. Thank you. Thank you to explore.org for keeping this camera going in Churchill. It is awesome. I love this camera. It shows you unbelievable detail. The stars are perfect pinpricks of light. Love it. But more importantly is it gives us a sense of the auroral activity. And if you didn't already know this, is you can there's somebody who's controlling this camera, and they can turn it and pivot it so that it's pointed at the auroras. And that is so awesome. Thank you to whomever is doing that. You're probably in bed right now. You don't even know you're getting the praise but you deserve praise. And I'm going to keep promoting you. The Churchill camera is awesome, and I'm going to promote Explore.org, and I'm going to promote anybody who's been doing anything to support this camera. Thank you from the rest of us. Now, maybe it's not somebody in Churchill. Maybe it's somebody from southern latitudes that is just controlling the camera. But anyway, whoever it is, thank you. We can see over in the far left of the Themis imagers that the cameras have come on in Alaska now. So we're kind of watching as daylight arises, daylight emerges from the eastern horizon on one side of the screen. And then on the other side, it's just past midnight in Alaska. It's 1:35 in the Yukon. It is now 2:35 a.m. in the Northwest Territories. Still plenty of time for active skies above the Northwest Territories, above British Columbia, above Alberta. Local midnight is now basically just off the coast of BC. I should say midnight. The actual midnight is just off the coast of BC. So we could still have a major geomagnetic storm, and that geomagnetic storm event could lead to beautiful auroras for BC, for Alberta, for the NWT, for Yukon, and Alaska. That's what we're hoping for. Unfortunately, the data suggests that that's not about to happen. And I'm guessing when I flip the switch to end Astronomy North's first live event, I'm sure it'll happen moments later. And that there will be photos. And that somebody at some point is going to go and download this video or just watch it and say, wow, what was that guy doing up all night talking about the auroras? Well, the reason I was doing it is to support our responsibility as a nonprofit. We are focused on helping to raise awareness of the nature, the culture, and the wonder of Canada's northern sky. And this is a new feature we're going to offer this year. And it's for Northerners, but it's also for Canadians coast to coast to coast who want to learn more about the science of the aurora and want to get connected to space weather, get connected to the northern lights like never before. We have the tools, and we have some volunteers like myself who are ready to help out. And so I kind of think this may be it, though. I might be signing off. Let's just do one more final scan of the Themis imagers and see if we can see any sign of increased activity at this point. That would be the kind of thing that makes me continue, is if we start to see a surge east to west, and I'm not seeing it. So that means I'm maybe going to bed. And that's okay. I think that's okay for everyone who's in my life tomorrow. I think that's probably a good thing if I go to bed soon. I hope you guys are enjoying this broadcast, though. And I welcome everybody's feedback about how to improve this broadcast. So submit your comments, or I'd say send an email to our to Astronomy North. The email is pretty straightforward. It is info@astronomynorth.com. info@astronomynorth.com if you'd like to send some suggestions. I am new to this, so I'm going to be trying some different things as we move forward and putting up some more, I think, dynamic display modules on this screen so you guys have more data to look at, more things to look at. But I'll make this, I'll try to make the production value increase as we move forward. But I'm kind of, to be honest, this is kind of a raw thing. It's going to happen. A lot of this stuff is happening in real time. And I do want to say a couple of sort of last messages here. One is I want to make a big shout out to Ryan Hall, who is a weather forecaster in the United States who covers tornadoes. And I've watched and been a follower and a fan of Ryan Hall for probably, I'm going to say like 8 months now. I didn't, to be honest, know exactly what this gentleman was doing. And then I saw him in action, and I just was so impressed by what he's doing. So Ryan Hall is bringing science, the science of weather, to the public in a way that is just so amazing. And I'm going to get the full name of his live feed because I want you guys to go check it out. So Ryan Hall Y'all. Yeah, so the Ryan Hall Y'all, I guess, is the name of the YouTube channel. I'm going to see if I can pull it up here. Yeah. I'm going to put it on the screen here. Let you guys see what I see. Can you see what I see? I've got it on the left-hand side there. So Ryan Hall Y'all gives you a sense of some really severe weather systems. He's got lots of content. It is just an epic channel. And it's what makes it epic is that it has experts. He is an expert on predicting auroras. He's an expert on tornado chasing. He's an expert on clouds. He's an expert on weather. And he deserves a ton of credit because what he's doing is he's giving people a sense of what's going on above their communities or near their communities. And to be honest, tornadoes are a very different creature than auroras. I'll see if I can put him up here. Here we go. Tornadoes are a very different creature. His predictions are saving lives. And he's an entertainer. He's an entertainer in some ways, but he's a scientist. He's truly a science communicator. He's got the knowledge and he shares that knowledge. And then you add to that photography, you add to that professional analysis. And he's a cool guy. This is a great channel. I strongly recommend you go check out Ryan Hall, y'all. Huge fan of his work. And then he's helped inspire me to think of ways that maybe we can improve our information sharing around auroras. I don't think it would be fair, though, to just mimic what he's doing and suggest that it's the same thing. It's not the same thing. What we're doing in real time tonight is trying to get a better understanding of what is going on in Earth's magnetic field and then enjoying a light show. What he's trying to do is trying to figure out what's going on in Earth's, with regards to Earth's weather, in order to help save lives. So, big difference. But he's an inspiration. So, thank you, Ryan. The other individual I want to give a shout out to is Tamitha Skov. And Tamitha is the space weather woman, and she is an inspiration as well. She's been doing some really amazing work for the past few years. I'm going to just pull her up here. We'll do it this way. Tamitha Skov, space weather woman. There it is. And if you didn't already know who Tamitha was, go and check her out. Go and check out the Space Weather Woman, her YouTube channel. She has lots of different social media channels as well. But the YouTube channel I find to be extremely valuable and helpful. And you can subscribe to get all different kinds of information, whether you're new to to space weather, whether you're an experienced space weather enthusiast or scientist. She is a scientist, and she's actually now, I believe I saw she's now leaving her full-time job. I think she's going down to part-time maybe to do this work, which is information sharing around solar activity, space weather, and auroras. She does talk about auroras, not as much as I will be talking about auroras. I'm at the end of all of the different topics that she is so knowledgeable of. But I just want to acknowledge her because she's on the frontiers of space science communicators. She's on the frontier. She's breaking trail, and her knowledge base is far superior to mine. But more importantly, I learned from her on a lot of the science. But I'm also acknowledging the fact that what she's doing is truly exceptional. It really is. And so here's why I'm bringing that up. Any of the topics that I've mentioned today, chances are you can go to her one of her videos, one of her workshop sessions, one of her mini sessions. You can go and find out more information by watching one of her seminars. I really recommend that. I'm only able to touch on a few things on these live events. I really recommend you go and talk, or you go watch the experts in action. And she is an expert, and she can give you a really good sense of what's going on both on the sun and much closer to the earth. All right, so thank you, Tamitha, for all you're doing. Huge fan. And so that's kind of it. I think I'll stop my shout outs at that and just give one final shout out to anybody who joined this very cool first ever Astronomy North live event. I want to thank you for joining me tonight. I'm James Pugsley. I'm a volunteer with Astronomy North. We're located out of Yellowknife, Northwest Territories. I live in Whitehorse, Yukon, but our society is based out of Yellowknife, the home of the Aurora Max Observatory. And if you're interested in learning more about Astronomy North, it's pretty easy. Go to astronomynorth.com. I'll put that up. Selfless promotion. And go to astronomynorth.com, and if you're interested in learning more about some of the projects and services we offer, go and check them out. You can also go to the Aurora Forecast, and we provide an Aurora Forecast for 9 northern communities, and that's likely going to be expanding as we move forward. And our goals and our objectives are largely oriented around education and outreach in the north. But with this new live event feature, we're not just reaching northerners, we're reaching Canadians coast to coast to coast. And maybe we're reaching you in Europe. Maybe we're reaching you in the United States. And this is something new, and we hope you like it. And yeah, so if you want to learn more, go to astronomynorth.com. If you have any questions or suggestions about this live event or about geomagnetic storms in general, send an email to info@astronomynorth.com. I'm James Pugsley. I want to thank you very much for joining me tonight. And we'll do one last check. One last very final check of what's going on the live feed cameras. Let's go back to... Probably see if we can go to the live feed in Alaska now too. So let's go to our explore.org cam. See if I can pull that up here quickly. Oops, that's not it. Northern Lights cam live from Churchill. To get there, I went to explore.org, or you can go through the YouTube, just straight through YouTube. And yeah, guess what we're seeing, ladies and gentlemen? We are seeing the arrival of the day. Like literally, this is daylight breaking in Churchill. And so thank you to Churchill for all the broadcast tonight, for your support, providing us with this awesome video footage. Couldn't have done it without you. Really nice feature. And a lot of the other cameras in Canada aren't yet on. We have the Themis Imagers, we have the Churchill camera, and there are some other imagers that I didn't feature tonight. But hey, it's a first. This was a first. Got to start somewhere. And so let's just do one last check. I'm going to see if there's anything on in Alaska. Oh, I should give a shout out to the Aurora Notify as well, which is based out of Alaska. Yeah, Aurora Notify is awesome. They are, I think it's a volunteer who's just out constantly promoting, hey, get outside, enjoy the lights right now, get out there right now. I love that. They're doing awesome work. Yeah, I'm not seeing the cameras are on in Alaska. No, not the ABN. See what's going on at the Geophysical Institute. Yeah, that camera doesn't appear to be on. Alaska Aurora Cam. I'll put it on the screen so we can all see it. Yeah, I'm just guessing these cameras aren't on right now. Yet. Oh, this one might be. Nope. That's 2021. Those are directional cameras too, so it's not an all-sky imager. That's not a criticism, it's an observation. So, yeah, we don't have a lot of data coming in from Alaska right now. Is this one showing live from Alaska? Nope. So there you have it. I think we're done. And maybe we'll just sign off. I'll leave the Churchill camera running as we wait for sunrise. Thank you, everyone, for joining me. Have they stopped? Has the camera stopped? I think it might have stopped. Oh, no. I just pressed play. It's now started again. Thank you, everyone, for joining the Astronomy North live event tonight. Keep an eye on the northern sky. Watch for increased activity over the next 24 hours. We could very easily have a geomagnetic storm event in the next few hours. But our data is suggesting it's not happening right now. So with that, I will go to bed. And I wish you all safe viewing, happy viewing. Enjoy the show.